basically there we go. So a long-standing attendance of the EESSI development, say the development talks given by Kenneth and among other people, and it was initiated in Cambridge. We were there as well, so we also said, well, we want to participate in EESSI, also in EESSI build. So for a couple of years ago, we decided to go with spec instead. So we're doing that right now. But I'm always interested in sharing software stacks across, let's say, multiple boundaries, going to laptops and workstations, as opposed to solely running it on HPC systems, because we see that a lot of people are now asking all kinds of software and variants and extra libraries, which it's getting hard to, let's say, accommodate all these wishes. So instead, we want to have some streaming, let's say, platform like EESSI to either distribute EESSI build or, in our case, spec to the users, so that they can build them software themselves if they need some dependencies for their software. And also we have it centralized, because nowadays we have this software stack on Delft Blue as our biggest cluster at the TU Delft. But we also have different clusters with their different software stacks. And we have education rooms where all the PCs have yet another version of different software stacks. So this is why we want to consolidate those stacks into one, and also use EESSI for distributing these stacks. But yeah, so that's basically what's going to be my project. At least I asked my manager, saying, well, I have this idea of streaming it to university with either spec or EESSI build. And he said, fine. So now I am in the progress of requesting a VM for the tier, I think it's going to be tier 1 system at the Delft, at the TU Delft. And then I probably need some proxies, and I also probably need some help setting all these things up, because I have played a bit with CernVM and also a bit with building stuff with EESSI, which went fine, by the way. I think in a hackathon I ran lumps on a Neoverse V1 using EESSI. That went fine. So that gave me confidence that this solution would work on our, let's say, on our campus, on our university. And yeah, I'm now looking for some good tips on how what a VM I need for an EESSI, let's say, tier 1. And I already looked a bit at. I also talked a bit with a administrator from Groningen. I think it's a colleague of Bob Dreugen. And so yeah, so that's he said, well, basically you're fine with a 4-core system, but with a bit more let's say storage, about a terabyte or half a terabyte, which is a bit of a problem using a VM. But so I was wondering what thoughts are you having about running a tier 1 system, and what are your recommendations on yeah, what kind of hardware or what kind of resources I need.
Okay, so first, welcome, and we're glad you're sharing your experience and your questions. So we'll start by introducing what EESSI Happy Hour is, and I guess you already started getting some responses for your questions on the chat, but I hope we covered some points that you're mentioning in this and in upcoming EESSI Hour sessions. So hello everyone, and welcome to the very first EESSI Happy Hour. I'm really glad to see you all here. This will be a weekly get-together every Monday from 14 to 15, where we'll talk about all sorts of easy related topics. So think of this happy hour as an open space for sharing, asking questions, and exchanging ideas. Just note that this session is being recorded. Recordings, slides, and materials used will be made available publicly short after each session. And since this is the very first session, I would like to have a short introduction about what EESSI is. So EESSI, the European Environment for Scientific Software Installations, it's a community-driven effort to provide a shared high-performance and easy-to-maintain software stack for scientific computing. So the idea is simple but powerful. Build software once using well-tested, reproducible methods and make it available everywhere. So researchers and HPC centers don't have to reinvent the wheel each time. So EESSI is a shared repository of optimized scientific software. When we say optimized, we emphasize that it's optimized per CPU architecture. It's a uniform way of providing software to users, regardless of the system they use. It should work on any Linux operating system, even if it's a Windows subsystem Linux or Mac OS via Lima. From laptops and personal workstations to HPC clusters and cloud. So EESSI could be used on every single workstation or laptop or cloud infrastructure or HPC system as long as it's under Linux. It supports for different CPU microarchitectures, interconnects, GPUs. So the focus is on performance, automation, testing, and collaboration. Now we will just go on some points where the latest updates on EESSI. So what we can confirm is now that EESSI is at least available on 40 systems/clusters, which are giving access to EESSI. Those are different clusters with different architectures. There are 507 software packages currently available in EESSI. Lately, OpenFOAM test has been added to EESSI Test Suite. And last, there is a hackathon session in the wake of Euro HPC User Day 2025 in Denmark. So you can scan the QR code to register for the event. Now, what I will do is I will show you how simple is to load modules from EESSI. This is a VM where I already have EESSI available. So if I do ls/CVM-FS software, and if, sorry, there is this sharing screen, it's a bit. So as you can see, I can access CVM-FS software.easy.io, and this is because CVM-FS is already available on this VM. All I have to do is source/CVM-FS software versions. Now you will see two versions. In later sessions, we will be covering what 2025.06 is. Init bash, and that's it. Now, as we can see, the script automatically detected there are no accelerators on my VM. I am using an x86-64 Intel Haswell. It automatically managed to use the module path and the software stack available for Intel Haswell. So this stack is specifically built to take the advantages of the Haswell architecture. Now, if I do module avail, for example, GrowMax, I will see that I have different versions of GrowMax available. Also, if I do module avail OSU, again, different versions of OSU available. Simply by loading those modules, I can start running the software available through EESSI. So all I had to do here is make EESSI available through the CVM-FS or any other way that we will be presenting in next sessions. For this session now, I will exit this VM, go to another VM, which I called Happy Hour. This is a fresh VM, nothing installed at all. So if I do RPM minus QA CVM-FS, I can see that there is nothing available. Checking our EESSI website, you can see that under the EESSI installation and configuration, there is something called native. Very simply, I will just copy and paste the steps mentioned in the documentation. So I will go to copy this, paste it on the VM. It downloaded the CVM-FS package. Next, there are 5 steps. I will go sudo CVM-FS install, which installs the client. It should be done. My VM is pretty tight in memory, so I'm trying to show with a minimal VM that I get access to the whole software stack. And also now I need to install the configuration through the EESSI latest Notch RPM. And basically those are the main steps. Now all I have left to do is to configure my CVM-FS client. With the next command, I can see that I am just pointing to what file to use for the client configuration. And finally, I have to set the size of the cache. Now here you should be a bit careful for the available resources you have. So within this settings, I set the size to 10 gigabytes. If you have a smaller VM or some size requirements, just be careful for this. And now all I am left with is just to execute sudo cvm-fs config setup. And now if I do ls/cvm-fs software.eeessi.io, it will try to contact the server cvm-fs. And then, as you can see now, I got access to EESSI and I will do the same steps, or I will repeat the same steps that I did earlier. So if I do now source/cvm-fs software versions 2023, maybe this is clear now, 06 init bash. Again, I loaded EESSI, and again, it detected there no accelerator on my VM. I have x86 64, and it chose Haswell, which is the best match for the architecture I have. And again, if I do module avail GrowMax, I see that I'm seeing what I saw earlier on the previous VM. So as said, EESSI available on 40 systems and clusters. So with those simple steps, you can get access to EESSI on any VM. It's good to mention that following this procedure, you need some sudo rights, else you will not be able to install CVM-FS. Again, in upcoming sessions, we will be covering other aspects of getting access to EESSI. To further test things, I will also go and clone the demo repo, which is also available in EESSI Docs, and try to run some random tests. So git clone. Copy again. There was something wrong with copying the link. Copy. And this clones the EESSI demo. In the EESSI demo, we have some sample scripts which we can run. So if I now go to cd EESSI demo ls, we can see that there are some already prepared recipes for bioconductor, espresso, Gromax, Nextflow, PyTorch, TensorFlow. So if I go to cd, for example, Gromax, I can see that there is this run.sh. If I have a look what it does, basically it tries to load a Gromax module, tries to fetch some files as a sample from Gromax to run a test, and then it will execute the Gromax MD run to run the simulation. So if I simply go to /run, I will see that at the first run, it will try to fetch Gromax from the stratum to the cache, from stratum 1 to our cache, and then it's executing the command. And as simple as that, now I have Gromax running and doing some simulations. So with just a few steps, I got access to a whole software stack optimized for my architecture. And in case your architecture is not within the architecture supported by EESSI, it will try to load the generic. It will not be an optimized software stack, but at least you can get the access for almost 507 different software packages available. So now on my simple VM with limited resources, I am running Gromax. Meanwhile, until the run, it runs the simulation, I will check for questions.
There were no questions specific since you started the presentation.
Okay.
So maybe once I don't know how long it runs, but otherwise we could start discussing what Franciscus was asking about.
Yeah, sure. And
Should I repeat maybe the question, what I understood? Yeah.
yes.
So I think Francisco is interested in how to set it up, which components should be needed, necessary, recommended, which are necessary. Also then maybe on the sizing of these different components. Yeah. So for example, you mentioned already a bit the cache size on a node. Yeah. And then if I understood Francisco's correctly, then you're looking into a setup for a whole cluster.
Yeah, multiple. Yeah.
Yeah, multiple clusters. Okay.
Yeah.
Yes.
Yeah. Sorry. Go on, Thomas.
Yeah. So I think if you look into CernVM-FS, then you have this central server, which you don't have to worry about. That's a Stratum 0. And then there are mirrors, so-called Stratum 1 servers. So they have always the full copy. Yeah, and there are a couple of public ones, I think at least two. Maybe there's a third one being set up right now. And then also everyone can have their own private Stratum 1. And we have documentation for how to set this up. These Stratum ones, which have a complete copy, they are good for increasing reliability. So in case of some connection fails to these other public Stratum ones, or maybe they would be overloaded or so. If you have close to your several clusters a full copy, that increases reliability. And then on each of the systems, you would probably want to have a proxy or several proxies. That depends a bit on the number of nodes you have in each system. I think the rule of thumb is something like one proxy per 500 nodes, if I remember correctly. Yeah. I think on the sort of the CPU needs are relatively modest, I would say. Not so big needs there. The network connectivity for the Stratum 1, private Stratum 1 is probably also not so much needed, at least the outgoing, yeah. And but then for the proxies, for example, you would want good connectivity best on your high performance network if you have one in the cluster. Yeah. On terms of disk space, I'm not entirely sure, but the whole software installations we have on our Stratum 0 at the moment, I don't know, maybe it was about something like 300 to 400 gigabytes at the moment.
I think it's getting closer to 500. Yeah.
Okay, so it's a little bit increased.
But that's for easy, of course. I'm not sure what Frank is looking for. If you want to build up your own thing from scratch,
yes,
then it depends a lot on how much stuff goes in there. And
yeah.
Okay.
Yeah.
So currently, I've just built 2025 spec stacks. I've built 4 different types of systems, and each stack is about 40 gigabytes.
Yeah, but one important detail there is for your mirror server, your Stratum 1 or Stratum 0, CernVM-FS does deduplication. So any files they have multiple times, it will only store once.
Yeah. So I do have generic builds for things like which are not CPU performance critical, like usually use that for GPU servers because they can vary in amount of NVIDIA accelerators. So sometimes have an A40, sometimes have a V100. So you can build a lot of these software installation with multiple versions of your CUDA architecture. And then we use a generic CPU build, just so to make sure that every type of node gets to run the software, and at least with an accelerator, with the accelerator performance of the software. So this is how we do it.
Have you done any benchmarking on that? Because in EESSI, we're now looking into deploying CUDA installations as well, and there we're going the other roads. We're still doing CPU-specific optimizations, and we're combining that with every GPU we support, which makes things explode. But yeah, we don't want to sacrifice performance there.
I understand, but so our bottleneck is basically our file system. We use a BGFS file system for storing the software. Maybe not the best of solutions, but currently it's the only storage solution which is inside our Delft Blue cluster. And that limits a bit on how much stacks and how, let's say, diverse the stacks can be, because every extra file, 1,000 files, adds loads to our metadata server. And so we want to be conservative, and also we have node types for the GPUs. So we have a V100s with AMD, and we have an A100 node type with Sapphire Rapids. So these GPU systems are pretty far apart, and having separate installation for each of these systems is it's 40 gigabyte each. So we tend to try out and see if performance is adequate for most of people, or if they say, well, we need something better, we need something faster, and it's also dependent on how how the software is being used. I mean, we have a lot of general users, students, master students, and some of them are researchers. We sometimes have their own software or build the software against our stack, and so it's pretty. I don't want to overcomplicate stuff, because we already see that when you build stacks for certain architectures, sometimes a build goes wrong because the architecture supports some kind of directives, processor directives, which the compiler handles differently than other more generic processor architectures, and then you get into problems. So this is why we chose to be as generic as possible if it doesn't hurt performance too much. So this is our reasons of doing generic builds for the GPU systems.
You mentioned metadata access and that it's overloading your file system, let's say. With CernVM-FS, that's a lot less of a concern, because a lot of the metadata access are basically pulled to the node itself. And it's hitting that cache first. As long as it's in the cache, you'll never hit the server.
Yeah, this is also a reason why we think EESSI is much better suited for things like these kinds of cluster installations.
This is not easy. It's just pure CernVM-FS. We didn't do anything special.
Yeah. Okay. Yeah, that's yeah, you're right. But yeah, we'll see. We'll see if it's.
No, it's. I think we have a system where we also use BGFS, and we see similar problems that so certain types of runs where you start many small tools in your scripts, and then you of course you duplicate that because you have many runs of the same kind of job. They overwhelm the metadata servers.
Maybe a naughty question to you, Frank. Why are you going with your own software stack that you're building out for the systems you're interested in, and not try to use EESSI or collaborate with EESSI? Is there anything holding you back there?
Well, basically, I offer a service to the HCP team, which is basically the owners of the Delft Blue system. And they preferred spec in the first place. Okay. So this is why I also wanted to introduce EESSI to them, because they have experience using spec at the University of Erlangen. And initially I was like, well, do we want to go spec or EESSI build? And well, of course, spec does have some advantages. I mean, EESSI build as well, because we have a good ecosystem of EESSI build users in Holland. So most, if not all of them are running EESSI build. So yeah, we just decided differently, but I want to bring them more together. So combining spec with EESSI and CernVM-FS to have a bit more choice for the users, and making our software support a bit easier, pun intended. But because people also run that serve, and they see EESSI stacks being handed out, so I think it's a good thing to at least diversify and point users to where they can get support, or if they can find somewhere a stack with their software pre-installed. I mean, having more is always helpful, as long as people are knowledgeable about what software they are running and how to reproduce it, because that can sometimes be an issue. I hope that answers your question, Kenneth. I mean, I understand that it's our way of, let's say, of handling the situation at the time.
Well, this is something we cannot prevent, and we're just interested why you're going with your own solution rather than picking up EESSI as it is. And that said, I mean, we have been interested in making the connection between spec and EESSI already. I shared the link to that.
I
support issue. Yeah.
It's very nice.
It's just very early stages, but we've been talking to Todd Gamblin on this as well. We're getting some support from him on how to do this. I think this is at least a good source of information for you to play with Spec on top of EESSI.
Yeah, because also Spec has now released version 1, where they have decoupled basically the Spec core and the packages. And I think that's very essential in having some solution which can connect with EESSI, because now you're not dependent anymore on, okay, this is not in the spec, I have to upgrade my entire spec software. And that is really a pain, because every year it's the same problem again. And then you have to, it's the same but different problems, and you have to solve them. And
they finally have a stable ABI, so that could help a lot. It's true.
Yeah. So
it's also something we were more or less waiting for to really seriously play with Spec on top of EESSI, because if it's a moving target, I mean, we cannot keep reevaluating them.
But now with Spec packages as being a separate repository, then I think things will be a lot easier to incorporate.
That's funny, because quite quickly after EESSI build became popular, the first thing that people were asking for was to make it one single repository, rather than having the split brain kind of thing. And Spec is going the other way. That's a detail. There's downsides and upsides to both approaches, so you just have to pick one.
Can
I ask a question, Frank? I'm just wondering, so is CernVM-FS then the only component that you're planning to use from EESSI, or are you also looking to leverage the compatibility layer, for example? Maybe the architecture selection tools or stuff like that?
So that's a good question. So we do see what our main problems are when upgrading these systems is that we have to upgrade the OS from Red Hat 7 to Red Hat 8, and now we already have to decide whether we should go Red Hat 9, and we should,
10
or 10 even, but that's support is a bit lacking for our systems at the moment. But so having this Gen 2 layer is very helpful, because then the problem with Spec is that it can also pick up external dependencies. You have to be really careful about that, because Spec can find anything you want, but as soon as it gets linked in and you upgrade your OS, things start going wrong. And we have been bitten by UCX and OpenMPI. It turns out that Red Hat has let's say, deprecated a way of finding your InfiniBand or your fast network, and suddenly our OpenMPI start crashing, because Spec has seen that the UCX is now a new version, so it took that. So we had to redo our OpenMPI builds, and so having Gen 2 as basically a stable base would help us in that aspect, that we can roll out these stacks on different systems running different OSs, and not worry about, oh, it's Red Hat 9, oh, it's Red Hat 8, oh, it's a very legacy system with Red Hat 7. But so we are interested in that compatibility layer as well. But first, we should get it running anyway.
You're of course preaching to the choir here, right?
No, I mean, I'm just curious, right? Because then I don't know what the support in Spec is for building against a custom sysroot, because that is something that we've introduced in EESSI build basically because we were working on the EESSI project, right? And it's still ongoing, right? We're still hitting issues every now and again and need to fix things. I don't know how aware Spec is of OSs that reside in a different prefix.
I don't know either. I usually use OS as a host to building the Spec stack, and then I use it on the same host. But I expect to have significant problems when I'm going to port or move that entire stack to a different Red Hat or maybe CentOS system.
Yeah.
And let alone let's say Ubuntu and Debian, because I don't dare putting a stack there which is has been built on a Red Hat system. I don't think that's going to work at all.
No, you'll hit problems very quickly due to the glibc. That's different in those OSs. But
Yes.
what Caspar is really saying, like this compatibility layer we have in EESSI, that's also sometimes called an alternate sys root. Like the root of your file system is just somewhere totally different than it usually is. And EESSI build, we have lots of small changes left and right to make builds aware that they're being built against such an alternate sys root. And what Caspar is saying, and which I also don't know the answer to this, is to what extent SPAC is aware of a setup like this. Like, can you tell it you should use the glibc from this weird location and not the one in userlib or userlib64? To the best of my knowledge, SPAC doesn't have a feature like this, and I've seen it being discussed in the SPAC Slack a while ago, but I don't know if anyone has really looked into it. And if that's not the case yet, there's probably quite a bit of surprises that will need to be fixed in.
It's already good that they have now runtime support for compilers, so the GCC runtime packages, because it's really annoying to let's say build the software with a GCC from spec and then finding out that it doesn't work together with glibc or another package which uses LLVM. So that has already been, let's say, handled by using these runtime packages, which other packages can, let's say, point to as dependency, which is really nice. So you're not hooked up to one compiler on your whole stack, which is really annoying the previous stacks. But yeah, for the sysroot, it's a good thing you mentioned it. I'm trying to look it up. It would be, of course, helpful, but yeah, I mean, if the situation has already been solved with EESSI and Gen 2, so.
Well, the compat layer will solve all those problems that you mentioned, but whatever tool you're using on top of that has to be aware of this middle layer in one way. And in EESSI build, we have features for that. And SPAC, as far as I know, not yet. Of course, that could be worked on, and it's not impossible. But that's one of the things that we would also be hitting quite quickly when we play with SPAC on top of EESSI, for example. One of the first things you need is you need to be able to tell SPAC, like, use the libraries from this compatibility layer and not the ones from the host OS, or things will just fall apart.
Yeah. So the packages, YAML, can do that for you. Basically, for each library, you can specify in spec that you should not build it, but there's a version which is located this and that.
Does that work for glibc as well?
I haven't tested that.
Yeah, that's the important one, and that's not the only one.
No, you're right. But in a sense, glibc is also a package in spec itself, so you can.
Yes, it is. Yeah.
And let's say using that is, I think, a bit dangerous, and that needs to be tested thoroughly. And so far, I didn't have a use for or a need for building my own glibc.
Why do you think it's dangerous?
People people who are trying to build against that stack spec will see problems when they try to use debug, let's say, builds. And it turns out that debug symbols are not compatible between compilers with glibc. So I had I had bugs when I built a stack spec, and some packages, and this is also a bit of a problem with spec, is that the quality of the package, Python package frontends they vary a lot. So for renowned packages like Romax, OpenFOAM, they're absolutely fine. But if you need some kind of obscure library, it turns out that it hasn't been updated for quite some time, and it picks old dependencies, and also it builds with -G. And suddenly you have a library with debug symbols from a different compiler or different glibc than the others. And then they bite each other when you try to do a debuild and you try to run a debugger on it. And then the only thing you could do is basically strip the entire debug info from that library, and then it's usable again. So that's something I've seen, let's say, a couple of weeks ago when I was trying to test my current builds, and I was bitten by that. So yeah, what can you do? You have to find these packages, take out the -g option. You basically have to hack the package Python file, and then rebuild, and hopefully it's all going to go well. So these things I've seen, but that's, in my opinion, solvable and fixable.
Yeah, there's no fundamental broken thing in spec for sure, but it
No.
may be missing some features or some configuration options.
Yeah.
I like where this is going, Richard. I think this is exactly what we had in mind for this happy hour sessions, right? These lively discussions. We should also check if somebody else has any questions, because it's been a bit of a two-way conversation. But
In chat, I can't see.
no, but maybe I don't know, Jan or Loris or anyone
Yeah.
else.
And we could, if someone doesn't, sorry.
No, that's fine. That's fine. That's the easy hour, so we can all talk together.
Also,
one thing that might be interesting also to Francisco is that in the upcoming sessions, we also might be trying to show how to get access to EESSI, might be without even CVM-FS, other approaches. So you might be interested also in having a look into that. So keep an eye on the EESSI Happy Hour.
Yeah, you're recording it, right?
Yes. This is recorded. Every session will be recorded and then will be also made available later on.
Okay, that's fine. That's very nice.
Yeah, I just wanted to say, if, for example, you want us to talk an hour about a very specific topic, of course, we could try to prepare a bit. Someone could also share maybe experiences, and then we could have a conversation about that. Yeah, so we would want to be open there. And then I just wanted to say to those who maybe could have questions and don't, maybe a bit too shy to ask a question when we record, we can also stop the recording before you ask a question.
Sure.
Yep.
Also, in case anyone just remembers to ask a question or has something to share with us, also you can find us on the Slack channel. So we are always there to support any question.
Yeah, I mean, if there's nobody speaking up or posting questions, I guess we can continue the conversation a bit. And I think we do want to end this at exactly the hour, right, Richard? So
yeah,
keep it limited to 1 hour in total.
Yeah. Basically, the maximum is 1 hour, but we can continue discussing the subject if Francisco is still open or anyone has a question or anything to share. Yeah.
Well, I just had a question, Frank. Are you planning to play with this in the coming weeks, months? Spec on top of EESSI or building out your own thing or whatever you want to do first?
I think the first thing I want to do is get a Stratum 1 system inside TU, because now I don't want to see a spec command anymore in the coming weeks because I'm pretty fed up. But yeah, we need some kind of Stratum 1 system just to run it and just to see how it feels. Maybe we have to find some proxies. I think that would be. I don't think it's very hard to build or to create a Stratum 1 server, but I think it's much more, let's say, problematic to have a proxy installation.
Yeah. So a Stratum 1 is a mirror, right? So that would be a mirror for EESSI. Okay. If you want to host your own repository and start from scratch, then you need Stratum 0. So Stratum 0 is the central server where you can create and host repositories. Stratum 1 is what you typically put close to the cluster to mirror repositories. So that's what you would do for EESSI, for example. If you want to set up a mirror, and then you can do proxies if your system is big. Yeah, it's definitely recommended to have a couple of proxies.
Yeah, And in all cases, I want to support EESSI because the rest of the Netherlands is also running EESSI. I mean, EESSI build at least. The EESSI is running on Serve now on Snellius, and I think that's we can start there and then see if people are enthusiastic about it. And for us, then it's a way to test if our configuration is fine and if our bandwidth is big enough. Then I can probably start building a Stratum Zero for our builds, like spec. Yeah, and then see how that unfolds. So we'll see.
Have you seen the tutorial we did a while ago? The best practices for yeah. So that
we've seen all of them. Yeah. So
yeah, that has very good information how to set up a Stratum 1 mirror server and all the details.
Yeah.
Do you have any ability in your VMs to do you have a local disk there or something, or is everything networked?
I don't know actually.
Because that would be ideal for at least the Stratum 0 and the Stratum 1, right? So for Snellius, we have a private Stratum 1 on one of the service nodes, and there the data is actually being stored on NVMe drives. And that single Stratum 1 can serve the entire cluster. I've done a test with, I don't know, 90,000 ranks or something, all trying to import TensorFlow. I mean, then it just caches stuff as well, right? So it's efficient. Yeah. But yeah, I think that should be in terms of I/O, that's the ideal solution, right?
Yeah.
Because then you have a very fast I/O on your Stratum 1, and you can have a lot of nodes asking different amount of data from that Stratum 1.
Yeah. So our VM solution is vSphere. And we have dedicated cabinets for that. But recently, we have seen storage issues. Basically, having storage is now a problem.
Yeah.
So, or getting it, basically, I would rather say. So I'm looking into also physical servers.
Yeah, I mean, I would definitely not let it stop you for experimenting, right? I mean, that is an easy way to get started and build experience. But as a, let's say, production solution, I think a physical server with some fast local storage, I think is the best option.
Yeah. So we do have, let's say, spare or let's say systems in our cluster which are not being used right now. So the notion of having a private Stratum 1 is appealing, at least for Delft Blue, and see if that works. Because that node is now doing a cluster cockpit, let's say, running a cluster cockpit installation. Still have to tweak that a bit, but it has very low system requirements. So might as well put a Tensor Stratum 1 on there as well. So we have, but we'll see. We'll see. Maybe I need a separate node anyway. But we have some available at least. Minus the storage. So we need to buy that anyway. Oh, there's some more links on the chat.
Yeah, this is just a tutorial that you know about already, and the webinar series we did a couple of months ago.
Yeah, that was fun. I watched them.
Yeah, so we regularly try to do some of these training sessions.
Yeah, I was in fact gonna mention that while closing, that everyone who's interested in more details about each of the subjects we're gonna be presenting in the EESSI Happy Hour, they definitely can find more information in the webinar series, which was held between last May and June. And it can be found in the training tab within the EESSI docs.
What's the next topic next week?
The next topic based on our agenda is getting access to EESSI through EESSI container. That's the plan. But again, as you mentioned, if there are some ideas, some interesting topic, we can also go through that and schedule that for an upcoming session, add it to the next session. So if we go to training, EESSI Happy Hour, So as you can see, the next session will be focusing about Easy Container Script, which basically loads Easy within the container. So you don't install anything. Oh, now we're getting into the next session's information. But using the Easy container, you don't need to install anything. You don't need even sudo rights. But you're going to see that in the next session. And the one after will be covering other ways to get access to Easy besides CVM-FS and the Easy container. And I guess in the last session, we're gonna see practical considerations and recommendations, more or less to what Frank has been asking, like proxies, caching, sort of those tunings that are essential to get performance while using Easy.
And
Yeah,
then I
sorry.
guess we could keep a list of potential topics in the future somewhere as well. Like the spec on top of Easy thing
Yeah.
is now needs to be further explored first, I think, before you can really say anything
Sure.
meaningful about it. But at some point, that would be good to have. And maybe we can try and get Todd involved in that as well, just to make it a bit more of an interesting discussion session. Just show what we have run into when actually trying this and discussing what would need to happen on both sides to make it a better experience. So that may be an interesting topic. Maybe not one of the initial ones, but later in the year it could be interesting, I guess.
And again and again, we are open for some interest, subjects, ideas. For example, if Frank or anyone who's trying something and he sees that it's a good subject to share with us, some components from within Easy or Easy itself, the whole stack or whatever. So just try to reach us on Slack and we can try to arrange something, a specific session dedicated to discuss the subject. Yeah.
Yeah, and I guess whenever we plan the next meetings, happy hours after September 8, then we will just update the page here.
Sure, sure. So basically, the Easy Happy Hour is based on a theme. So each theme covers several sessions. First theme is getting access to Easy, and during this period of presenting the getting access to Easy, we'll see ideas like what the audience and what we see appropriate for the upcoming sessions to share. And definitely we're going to set the schedule and make it available. So I guess for today, we have reached the end for this session. And we also said what's next session we'll be covering. So I hope that it was good and informative and hope to see you next time.
Thank you. Thank you for attending, for hosting it.
Excellent. Thanks a lot.
See you next time.
See ya.
Yeah.
Bye-bye.
Bye-bye.